So in the plane scale, what we do is we measure two consecutive units, two side-by-side units we'll measure in the plane scale. But sometimes what happens is we need to measure three consecutive units. For the three consecutive units, plane scale is not feasible. So that's the reason we use diagonal scale. Here we use a diagonal principle in order to make the third consecutive. So already we have the main division. This main division we are dividing into subdivision. And this subdivision we are again dividing into sub of subdivision. Total 3 consecutive units we need to measure by using this diagonal scale. So main unit, subunit, and further division of subunit. So total 3 units we can measure. Example, meters. Meters is the main unit. If I divide the meters by 10, it will become decimeters. If I divide decimeter by 10, it will become centimeter. Okay. Suppose if you take kilometers, 10 to the power of 3 meters. If you take 10 to the power of 2 meters will be hectometers. 10 to the power of 1 meter will be decameter. So continuously 3 consecutive units we can measure by using this one. So next will be yards. Yards are divided into feet and feet are divided into inches. Okay. So like this consecutive units you will be making. So this is the main unit. So in the plane scale, if you want to divide, you can directly make meters into decimeters. But in this diagonal scale, we have to divide decimeter again into 10 equal parts. Water may be, suppose if you assume this is a 1 meter scale, this 1 meter scale I'm dividing into 10 equal parts. And this is 1 decimeter. We assume that this is 1 decimeter. This small is 1 decimeter. And this 1 decimeter also we have to divide to 10 equal parts. This 1 decimeter also we have to divide into 10 equal parts. How to divide these 10 equal parts? We'll be learning in the diagonal scale. So in the diagonal scale, it uses the diagonal principle. So with respect to this diagonal principle, we'll be making the divisions. Okay. So here we'll be learning the diagonal principle. So as everyone know, the diagonal. So this is a diagonal. By using this diagonal, we'll be dividing. Okay. So suppose if you say that this is a 1 centimeter. Example, if you say this is a 1 centimeter, can anyone tell me where is the exactly half centimeter? This is a point A and point B. If I want to locate exactly half of this centimeter, what is the value? AB equal to 1. AB distance equal to 1 centimeter. And if I want to locate half of the centimeter, AB by 2, if I want to locate AB by 2, what is the value?
0.5.
0.5 of AB. If I take 0.5 of AB, I'll get half of this one. So it will be at the center. So similarly, if I want to take 0.1, it will be somewhere here, 0.2, 0.3, 0.4, 0.5. Next 0.6, 0.7, 8, 9, and AB. Okay. So if I want to divide this one, I need to make this division. However small my AB is, I need to make the division. So that's the reason I will use the diagonal principle. So in the diagonal principle, what I do is I'll take a vertical line. And I'll mark the end point as C. So generally, if it is 10 distance, suppose AB, I can divide into 10 equal parts. Meters into centimeters, it is 10 equal parts. Suppose if I want to make feet into inches, then I have to divide it into 12 equal parts, depending upon your problem. Suppose in the problem, they say in terms of metric units, then you have to divide this BC line into 10 equal parts. You have to divide this BC line into 10 equal parts, and you have to join A to C as a diagonal. If you consider ABCD as a rectangle, you will be ABCD as a rectangle. You will join C to A, which is a diagonal. Now what you do is, this is my 9th point. This is my 8th point. This is my 7th point. This is my 6th, etc. So what I do is, this is my first point. So what I do is, after drawing the diagonal, I divide this one into equal parts. Then what I do is, I'll join this one till here. I'll join this one point to here. And if I make the vertical line, if I draw this vertical line, then this distance is 0.1 of B. Then from the 2, if I join this one and if I make this vertical, then this distance is 0.2. This complete distance is 0.2 of AB. So that is the diagonal principle we follow here. So first take AB of one subunit, this subunit. Already we have the main unit. After dividing the main unit, we get the subunit AB. We get the AB is the subunit. For this subunit, if I want to divide further divisions, I have to take equal divisions of 10. Any length you can take, and by using the dividing a line method, you can divide it into 10 equal parts. After 10 equal parts, I have to draw the diagonal. This is my C part, C point. I have to join this A to C. If I join 1 to 1 dash, I have to join this one. Draw the horizontal lines to all the diagonals, connecting the diagonals. Then I have to join this to 1 to 1 dash. And if I draw the vertically, this distance is 0.1 AB. If I join this one, this distance is 0.2 of AB. Similarly, this distance is 0.9 of AB. Similarly, this distance is 0.5 of AB. You will get exactly half distance. So this is the diagonal principle. And this can be asked as a 2 marks question. Explain the diagonal principle, they can ask as a 2 marks question. So any doubts, you can unmute and you can ask in the diagonal if you're not understanding. So this is the distance. Already you have the main is the 10 divisions. Already you have made the 10 divisions. This small distance is AB. Out of the small distance AB also, you draw the vertical line and you join this side. This is your height. This is any length. So this is any length. So based on this any length, you have to divide into 10 equal parts. And suppose this is my point 1. So I project my point 1 here. And if I project here, this distance become as 0.1 of AB. That is the main principle we are following here. Okay. So watch the video once. So here I'm drawing a line AB. Then divide BC perpendicular, divide BC to 10 equal parts. If it is a metric, you have to divide 10 equal parts. If it is a feet to inches, then you have to divide 12 equal parts. Then give the divide 9, 8, 7, 6, 5, 4, 3, 2, 1. Then you have to join AC, A to C. This is a diagonal for the rectangle ABCD. AC is a diagonal, and extend the lines. And after extending lines, with respect to 9, it will be 9 dash. With respect to 7, it will be 7 dash. With respect to 2, it is 2 dash, 1, 1 dash. Okay, these are the similar equal triangle. And if you measure 1 to 1 dash, it is 0.1 of AB. If you measure 0.5 to 5 dash, it is 0.5 of AB. That is the main thing. So if you take 1 by 10, it is 0.1 of AB. Okay, 1 to 1 dash distance. If you project it, same thing will be projected here. 1 to 1 dash distance is a 0.1 of AB. Okay, 9 to 9 dash is a 0.9 of AB. This line is 0.9 of AB. Okay. Yeah. Okay. 5 to 5 dash is a 0.5 of AB. Okay. So we use the same principle in this our example. We use the same principle. Okay. So if I want to divide this smaller length, how small may be this one? If this is a smaller length, I'll divide this line into 10 equal parts. Then I'll join this one. Then I join this one. Then I can divide this AB also into 10 equal parts. That is the beauty of engineering drawing. How small may be the line, you can divide into 10 equal parts. And you can measure the sub of subdivision. Third division, third unit you can measure. Okay. Yeah. So this is only for the short answers. It cannot be asked for long answers. If they ask, explain the principle of diagonal scale as a 2 marks, they can ask. So whatever I explained in the video, same thing. First draw the AB line, then extend the any length, divide this vertical line into 10 equal parts, then draw the diagonal. Draw the diagonal. Generally, I take this distance, any distance as 50 mm, so that if I divide 5 mm, then I can get exactly 10 divisions. Generally I take any length as 50, so that it is convenient for me. I'll divide into 5 mm, 5 mm, 5 mm, so that total will be 50 mm. I can easily divide into 10 equal parts. Okay, then join this distance. 1 to 1 dash will be 0.1 AB, and 4 to 4 dash will be 0.4 AB. That's the main concept we follow here in the Indian drawing. Similarly, the same thing has been given here. Okay. So construction of diagonal scale. So those who are practicing the plane scale, it is a continuation of the plane scale. So after drawing a plane scale, you have to convert that plane scale into diagonal scale. Okay. So here what we do is, first construct ABCD completely. You have to construct a plane scale completely. Construct plane scale completely. So what we do is, first one we will divide into some equal parts. Example, first one I'll mark that 0. Next 1, 2, 3, and 4. It means that I have divided this LOS, length of scale, into 5 equal parts. I have divided this LOS into 5 equal parts. And AD, this is my A point, this is my D point. The height of the rectangle, I am dividing, making it as 50 mm. In the previous plane scale, I am taking it as 5 mm. But in the diagonal scale, I have to take 50 mm, because if I want to divide DA, then it is easy for me to divide. It is applicable only for metric units. If I want to divide into 12 equal parts, suppose I want to convert feet into inches, then I will take this height as 60 mm, because it is easy for me to divide into 12 equal parts. 5 mm, 5 into 12, it is 60. So if I'm converting feet into inches, then I have to take the vertical height as 60 mm. If I'm using metric units, all the metric units are division of 10, so I can divide it into 10, make it as 50. So each division is 5 mm. Okay. Next one, take 1 unit. So already this is your rectangle you have created. Example. So you are dividing into 10 equal parts. So this 10 equal parts I'm making. This is my 1 unit. This is my 1 unit. I need to join this point. This is my 0th point. This is my 0th point. This is my first point, second point, third point, fourth point. So what here I have to do is, I have to divide the same at the bottom also. Divide the same regions at the bottom also. This 0 has to touch the 1. And you have to fix your drafter. When you are rotating, you have to fix your drafter. With the same angle, this 1 has to touch the 2. This 3 has to touch the 4. This 4 has to touch the 5. 5, bottom 5th number has to touch the top 6th number. Similarly, bottom 9th number, bottom 9 has to touch the top 10th number. That is the diagonal scale I'm drawing for that rectangle. Okay. So take 1 unit and mark the end point as EF. Then divide 0F line into, and divide OE line into divisions of subunit, and draw the horizontal lines for rectangle. Then draw the vertical, write the sub of subunit on the left side vertically. On the horizontal line, represent the distance to be measured as PQ. Okay. At the bottom, you have to write. Okay, so I'll be showing once again. So this is a complete explanation. So what we are doing is, this is my scale. This is my first division, 0. Then I'm dividing all the points. Don't draw the vertical lines in this scale. So what are this one? Next, I have to make, this is the division. Next, I have to divide this into 10 equal parts. Then I have to draw all the horizontal lines. I have to draw the horizontal lines. Then what I do is, 1, 0 will be touching the first point, and the 1 will be touching the second point, and the third bottom third point will touch the fourth point at the top. Bottom fifth point will touch the sixth point at the top. Bottom 9th part will touch the 10th point at the top. Okay. Then here, so in the plane scale, what we do is, here we write the main scale division. Here we write the sub unit of the division. Here in the vertically, you have to write the sub of subdivision. Suppose this is meter, decimeter, centimeter. So you have to write centimeter as vertically. And here you have to write LOS. What is the LOS? Same formula. What are you using for the plane scale? Same. You have to find the LOS formula, RF formula. You have to use the same thing. And here you have to write 1 dash, 2 dash, 3 dash, same thing, and you'll be joining. And suppose if you want to measure any distance, so how to measure the distance is, suppose I want to measure 2.45 meters. Example, if I want to measure 2.54 meters, in the plane scale you can measure only 2.4 meters. You can't measure 2.45 meters. So what we'll do is, so from here I'll highlight 2, 0 to 2. So 2 meters will be completed. From the main units, I will be taking 2 meters. From the decimeters, I will highlight this 2. This is 0, this is my 1, and this is my 2. Okay, this is my 2, and this is my 2, and this is my fifth value. Where this fifth value is touching the point, this is my 2, and this is my fifth line. Suppose this is my, I have divided to 9, 8, 7, 6 like this vertically. So between these 1 and 2, so I want to measure 4, 5. So this is my fourth point. This is my fourth point. On this fourth point, where it is touching this point, fifth line, where this fourth inclined line is touching the fifth horizontal line, that is my 45 decimeter. 45 decimeter, or that is the value. So 0.45 meters, that is the value. So I will be highlighting this line. So this line I have to mark as, here I have to mark the letter as P, here I have to mark the letter as Q. So bottom, one more line I will be writing here, and here I'll write PQ value. PQ equal to 2.45 and 45 meters. I'll be writing here. I'll solve the problem, then you'll be understanding once. Okay. I'll solve the problem, you'll be understanding once. Okay. Yeah. Any doubts, you can unmute and come on. Any doubts, you can unmute and come on. Are you any doubts? So everyone read the question once. So in this question, they are saying that construct a diagonal scale. In this question, they are saying that construct a diagonal scale with 3:200. So here they have already gave the, what is the ratio they have already gave. RF value. RF value, they directly gave the RF value in this problem. So after giving the RF value as 3:200, they are asking you to read 3 units. One is meter, decimeter, and centimeter. Okay, meter, decimeter, centimeter, they are asking you to define. And long enough. It should be long enough to measure. It should be long enough to measure. It should be long enough to measure up to 6 meters. So maximum distance is, maximum length of the scale is 6 meters. And on the scale, you have to measure 4.56 meters. Okay. On the scale, you have to measure 4.56 meters. That is the problem they are asking. Okay. So listen, I will ask few questions. You have to answer me. So first question, what is the PQ distance to be measured? Yeah, unmute and you can answer. PQ value. What is the distance to be measured on the scale?
4.56.
Which is that? Yeah, 4.56 meters. So 4.56 meters we have to measure on the scale. How we will divide 4.56? We divide it as 4 meters plus 5 decimeters, then plus 6 centimeters. Okay, so we have to measure PQ 4.56, 4 meters, 5 decimeters, and 6 centimeters. Next, we have to find RF value. What is RF value? What is RF value? So the problem that is they gave that RF value is 3:200. RF value 3:200. Numerator is 3, denominator is 200. And what is the maximum length? What is the maximum length? Maximum length of the scale. Suppose if you take your scale, normal 15 centimeter scale, maximum scale is 15. You can't measure more than 15 centimeters. Similarly, in this scale, what is the maximum distance you are measuring? You can measure 6 meters. So you are measuring up to 6 meters. You can't measure beyond 6 meters. So maximum length is 6 meters. What is the least count of this scale? Minimum you can measure on this scale. If you are creating this scale, what is the minimum unit you can measure on the scale? It is centimeters. So meters, decimeters, centimeters you can measure. Least you can measure up to 1 centimeter. That is the least count of this scale. Okay. Next, you have to calculate LOS. Can one tell me what is LOS value? Tell me the LOS value. LOS formula is RF into maximum length. And here the maximum length is in meters. You have to convert meters into centimeters. 1 meter equals how many centimeters? Yeah, 1 meter equals how many centimeters? What is meant by term centi? If you take any US, if you go for US dollar, they will say that cents. It means that 1 cent, 100 cents, they will say. Okay. Yeah, you have to respond, otherwise you won't understand anything. So here RF, they gave the value as 3 by 200. Then maximum length is 6 meters. Meters you have to convert into centimeters, so it will be 600 centimeters. Least count comes as 1 centimeter. You can measure least up to 1 centimeter on the scale. So you have to calculate LOS. Anyone calculated LOS value? RF into maximum length. It is 3 by 200 into 6 multiplied by 100. So here what happens is 0 and 0 get cancelled. And 2 is cross multiplied with 3. So the total distance is 9 centimeters. So the LOS is, you have to draw the LOS as 9 centimeters. Okay. So you can watch this video once so that you will be understanding. It's not playing. Wait for 1 minute. So here what happens is, this is the length of scale you have to calculate here. Then first draw the line AB. Because we know the length of scale, draw the line length AB as 9 centimeters and divide it into 6 equal parts. First one will be 0. First one will be 0, 1, 2, 3, 4, 5. Total length, you have to divide this 9 centimeters into 6 equal parts. Then divide the A0 into 10 equal divisions. Okay. So you have to divide, this is the main divisions, meters. This meters you have to divide into 10 equal parts. A to 0, you have to divide it into 10 equal parts. Okay. So after dividing 10 equal parts, you have to use the dividing a line method and you have to divide. Then from the perpendicular, draw the perpendicular, 10 equal divisions. So from here you have to draw a vertical line. Take this height as 50 mm so that you can divide 10 equal parts. Because decimeter, 1 decimeter equal to 10 centimeters. So I have to divide this vertical line into 10 equal parts. Divide AD into 10 equal parts. 0 to 10 you have to divide and join it, make it as a rectangle. Okay. After creating rectangle, you have to write here as centimeters. So this is main unit, subunit, sub of subunit you have to write. Then draw the vertical line from each division. 0 to vertical line, 1 to vertical line, 2 vertical line, 3, 4, 5. You have to draw this vertical line you have to draw. Then what you have to do is, divide this top line into, you are divided this vertical line. This vertical line, draw the horizontal line. Draw the horizontal line till the length of the scale. What is the length of the scale? A to B. So complete 9 centimeters. You have to draw this horizontal line. What you have made the vertical division. From the vertical division, draw the horizontal line. Then what you have to do is divide into 10 equal parts. Divide this AO into 10 equal parts. AO into 10 equal parts and D2 this point into 10 equal parts, and the ninth point should touch the 10th point. Bottom 9th point should touch the 10th point and fix your drafter. And here 8th point should touch the 9th point, and similarly 7th point should touch the 8th point. 6th point should touch the 7th point. 5th point should touch the 6th point. So like that, you have to draw this diagonal. By using this diagonal pencil, you are drawing the diagonal lines. So you have to draw all these diagonal lines. So after completion of this diagonal line, now you are drawing diagonal scale. 0 has been touched to one bottom one is touching the top two. You have to draw this diagonal line. Okay. Now your scale is completed. Now you have to measure 4.56 meters. Now you have to measure 4.56 meters. So already you know 4. So on this 4 line, next is the 5th. On the bottom, this is the 5th. So I can't show. Okay. So see here. So how to mark the point is, this is the 4th. From the 5th line, draw this vertical line. Already you have drawn this inclined line. On this inclined line, on the 5th inclined line, where the 6th horizontal line is touching, mark the point. On the 5th inclined line, this is my inclined line. On my 5th inclined line, where the 6th horizontal line is touching, that is my 4.56 line. Okay. Here see, inclined 5th line and horizontal 6th line, where it is touching, mark the point as either P or Q. Mark the point as P, and the end point where the 4 is touching, that is the Q. Okay. So this is the 5th point. If I draw the vertical line, it is this one, and this smaller distance is the 6th point. So you have to represent that is the PQ line. You have to represent. So this is a video link. I'll post this video link also in our class, WhatsApp group, so that you can see and okay. You can watch the video once again. Okay. So here I'll be drawing once again. So this is my scale. So this is my 5th point. So generally in the plane scale, what we do is, this is my 5th point and this is my 4th main division. So 4th, 5th small division, it is 4.5. Generally we take it as 4.5 meters. But if I want to measure, so this is my vertical line. Don't draw the vertical line, but this is my inclined line. So from here I'll be drawing the inclined line to the 6th point. 6th point will touch to 6th point, and whatever may be the distance. Suppose it is at the 10th. So this is complete one small division. So like this only. It is the same like this only. You have drawn this one. So if I want to measure the 6th one, so this is my 6th horizontal line. So this is my 6th horizontal line. This is my 5th point. This is my 5th point. So from here, this is my 0th point, and this is my 4th point, 4th main division. So if you see only this vertical line, it is 4.5. But if you take this smaller distance is 0.006 meters. This is the value. Okay. So this is a small distance making the change. This is completely 4.6. Then this is your complete 4.6. Okay. This is nothing but vertical line. If I draw here, this is my 6th point. If I want to measure 4.6, this is my 4.6. If I want to measure exactly 4.56, this is my 4.56, and this is 0.04 meters. This distance. Okay. That is the principle we use here in the diagonal scale. To measure the one more division, we use this one. Okay. So this is the problem. draw the ABCD line, then divide it into 6 equal parts. Okay, divide into 6 equal parts, and then again divide this into 10 equal parts. Again you have to divide here, divide it into 10 equal parts. After dividing 10 more equal parts, after dividing the 10 more equal parts, then you have to, then this is my fifth point. This is my fifth point. This is my fifth point. If I draw this vertical line, this is my fifth point, and this is my sixth point. Okay, this is my sixth point, and this distance is 0.06 meters, and this rest of the distance is 0.04 meters. Okay, that is the principle you have to use, and this is what your seniors have drawn. They took this distance as 50 mm. Take this as 9 centimeters, divide into 6 equal parts. First one mark it as 0. Divide this into 10 equal parts. Again divide this into 10 equal parts and divide this into 6 equal parts and make it. This will be 1 dash, 2 dash, 3 dash. This will be 1 double dash, 2 double dash, 3 double dash. This will be 1 triple dash, 2 triple dash, 3 triple dash, 4 triple dash. You have to make this distance. You have to divide 3 times. You have to divide this line once. You have to divide this line once. And you have to divide this line once. This line you can directly measure with the scale. If you take exactly 50 mm, you can take and you can draw this line. And this fifth point has to touch the sixth point. Where the fifth point and sixth point are touching, mark the point as P. This is the Q. You can mark. So this is the PQ line. You can mark. Okay. Any doubts you can unmute and you can ask. Anyone any doubts you can unmute and you can ask. This is the sixth question. So you have to draw plane scale 2 problems and the diagonal scale 1 problem. Okay. Any doubts you can unmute and you can ask. Any doubts you can unmute and you can ask. I will share the video link. So watch the video link once so that you will be understanding what is the principle of the diagonal scale. I'm going to the next slide. I hope everyone understood. Any doubts you can unmute and you can ask. Or else type in the chat. Because this question can be asked as a 10 marks question. So compulsory make sure that you understand and practice once. I'm going to the next topic. So this is also same problem. Don't draw this one, just listen. 1.2, 1 is to 32. The RFJ mentioned as 1 is to 32. You have to measure yards, feet, and inches. Okay. Then maximum length is 4 yards. And on this one, you have to measure 1 yard, 2 feet, 7 inches. Okay. So you have to calculate LOS. So LOS you have to calculate 1 by 32 into 4. Because maximum length is 4. Because the maximum length is 4 yards. 4 yards, 1 yard equal to 3 feet. So into 3 and 1 feet equal to 12 inches. So 4 into 3 into 12. It will become 4.5 inches. You have to convert inches into centimeters. 1 inch equal to 2.5. So 4.5 inches equal to 11.43 centimeters. Okay. So you have to calculate this one and first draw this line, divide it into 4 equal parts and again divide it into 3 equal parts. And this vertical line, I have to take it as 60 mm. I have to take it as 60 mm and I have to divide it into 12 equal parts. 5 mm each. And I need to mark 0 to 1 and 1 to 2 and 2 to 3. At the top, I have to join this one. And as for the problem, I need to find the distance as 1 yard, 2 feet, 7 inches. So where this 2 feet is touching the 7, that is mark the point as P or Q and draw the horizontal line. This is the 1. This is 1 and this vertical line is 2. So till here it is 2 and this distance is 7 inches. This is 7 inches. On the scale 7 inches. This is 2 feet. This vertical height is 2 feet. And from here, this distance is 2 feet. And this distance is 1 yard. So like that, you can solve the problem. No doubt solving this one, write only one. Okay. So this is what your seniors have drawn. It is not actually visible, but this is what your seniors have drawn. They have drawn this one as. Any doubts you can unmute and you can ask. Any doubts you can unmute and you can ask. You can expect a 10 marks question. on either plane scale, diagonal scale, or Vernier scale. Okay. Any doubts you can unmute and you can ask or else type in the chat. So next important one is Vernier scale. Can anyone tell me what is the least count of Vernier scale? Least count of Vernier scale. Anyone know what is the least count of Vernier scale? Least count of Vernier scale or screw gauge or micrometer, which you learn in your physics classes.
0.01.
0.01. So you can measure up to 2 units or 3 units in the Vernier scale. 0.01. You can measure 2 units or 3 units in the Vernier scale. You can measure 2 units or 3 units. Suppose there's a value of 4.56 meters. So least you can measure up to 0.01 meters. So it is a least count. So you can measure up to 3 units. In the Vernier scale, we can measure up to 3 units. Okay. The smallest distance can also be measured by the Vernier scale. If you want to calculate the least count, main scale division minus Vernier scale division, which make you can get the least count of the Vernier scale. So one least count equal to one main scale division minus one Vernier scale division. So Vernier scales are classified into two types. One is direct Vernier or forward or backward. Okay, there are two types of Vernier scales. One is forward or backward. Okay. So what is meant by forward? What is meant by backward? So what is meant by forward? What is meant by backward? Suppose if you take, this is my zero division. Suppose I take, this is my scale and this is my zeroth line. This is my zeroth line. So in this scale, which one is backward, which one is forward? Which will draw a line. This is my zeroth line. This one I call it as backward, this one I call it as forward. So from this scale, if I move to my left, this is my backward. I'm going backward. If I'm going forward, this is my forward scale. Okay. There are two types of Vernier. One is backward scale Vernier and forward Vernier. In the problem, they can ask solve a problem by backward scale. In the problem, they'll ask solve a problem Vernier scale problem by forward scale. So depending upon the situation, you have to use either backward scale or forward scale. So we will be learning what is meant by forward and what is meant by backward. Okay. So this is your scale. This is your scale. And this is your 10 divisions. First division we'll mark it as 0. And we are dividing this 0 to A line into 10 equal divisions. Okay. So similarly, this is the 9th point, 8th point, 7th point, 6th point. Okay. So in the forward Vernier, what we do is, this is my 10th point, this is my 9th point. So what I will add one more scale called Vernier scale from 9th to 0. I will add Vernier scale from 9th to 0. That is called my backward scale. So total how many divisions? Here we have only 9 divisions. Okay. If we are making 9 divisions, it is called forward scale. Okay. And similarly, if you go the backward scale, if you are using the backward scale, so this is my normal scale, and again I have made it as plane scale. In the plane scale, this is my main divisions, this is my sub of divisions. So what I do is, I will take one more unit. I'll divide this as 10th, 0, A to 0, made 10th division. So whatever maybe the 9th to 10th division is there, same division, I'm adding one more scale here. Okay, I'm increasing one more scale and I'm making it as 11 divisions. If I make 11 divisions, it is called backward scale, because this is your normal scale. From normal scale, I'll add 1 point. After 10 divisions, I'll make one more divisions. I'll make it as 11 divisions. It is called backward. From the 10 divisions, if I make one forward and I'll take only 9 divisions, then it is called as forward Vernier or direct Vernier, we call it as. Okay. So I'll explain once again so that you will be understanding why we are taking 9 and 10. Okay. Vernier scale has been created by Paul Vernier. He was an engineer and mathematician. So as a mathematician, he has seen the tables, different tables from 1 to 15. He has seen the different tables and he has observed one thing. Suppose if I want to make any 3 units, so what there are total 3 units, such as if I want to make any three division scales, such as main unit, subunit, and sub of subunit. So I suppose I'm taking this is my value 4.56. So he has observed the last digit. The last digit should contain all the letters from 1 to 10. All the letters from 1 to 10. He has seen this one, and he has seen few tables where the last digit of the table is 1 to 10. Can anyone tell me what is the last digit? Suppose there are two digits number, 1th digit and 10th digit. On 1th digit, all the digits should start from 1 to 10. What are the tables between 1 to 15? 1 to 15 table. In the single digit, it should be from 1 to 10. Any table? Already one you have, but one is only, it doesn't have the second unit. 10th division it doesn't have. 1th and 10th division. So on the table from 1 to 15, what are the tables where you can find the single digits 1 to 10 directly? Any table you can find? Yeah, anyone respond? 1 to 15 table, on the one side of the division, one side, it should be sequence of the digits 0 to 1, 0 to 10, or some 10 to 1, reverse or forward. Any divisions? Understand my question? Suppose it is example 71 is there. So you have to say a table such a way that after this one example 82 and 93, like that. If you see this side, it should be as a repetitive between 1 to 10 or 0 to 9. It should be like this. Any table where you can find this kind. So what the Vernier scale, Paul Vernier has done is he has performed, he has seen all the tables, and he has made sure that when he sees the ninth table, it comes as 9, 18, 27, 36, and so on till 90. Okay. So 9 ones are 9, 9 twos are 18. So like that, he has seen this digit has in reverse one 0 to 9 to 0. And he has performed -1 to the 10. And he has done +1 to the 10. It has become 11. So here what he has done is he's seen the last digits. Last digits are like 11, 22, 33. So these last digits are in 1 to 10. So what he has, by looking at this table, he has created the Vernier scale. Okay. So in the Vernier scale, what we do is this 9 divisions, we make it as it is taken as the 9th table, and when you take the 11 divisions, it is taken as the 11th table. Okay, so you have to take it in the if you are using the backward Vernier, you have to use 11th table. If you are using forward Vernier, you have to use the 9th table. You have to use. Okay. So Vernier scale has total these scales. One is primary scale and Vernier scale. Primary plane scale. So you have to construct a plane scale. On the plane scale, you have to create a Vernier scale. On the plane scale, you have to create a Vernier scale. So what are the Vernier scale? The Vernier scale is derived from the plane scale, primary scale. From the primary scale only you have to divide Vernier scale. Suppose the primary scale is in metric units, so Vernier scale will be in metric units. Suppose the primary scale is in imperial units, feet and inches. So you have to create the Vernier scale with respect to the primary scale. Okay. So this is the problem. In the problem, this is my division. I have divided this into. This is my subdivision. This is my subdivision. This subdivision I divide into 10 equal parts. Then what I have to do is I am explaining the backward Vernier. So listen. So whenever I am taking principle of Vernier, I am explaining. AO represents 10 centimeters. Example, AO represents 10 centimeters. And we are dividing this AO into 10 equal parts. Each represents 1 centimeter. Okay. Then what we have to do is we have to take what is the distance between this is my B example. So this is equal whatever may be the 1 centimeter distance. That 1 centimeter I have to add one more here. So I am adding one more here. What are the measure? I'll measure 9 to A. 9 to A is the 1 centimeter. This measure I'll add one more thing here. What are the I will take one division, one subdivision, and I'll add one more subdivision here. That same division length I'm adding here. Then what I do is this total distance between already this is 10 centimeter. I'm adding one more centimeter. Total become 110 centimeter. Total will become 110 centimeter. Then what I have to do is this 110 centimeter I have to divide into 10 equal parts. This 110 centimeter I have to divide into 10 equal parts. Each part will become as 1.1 centimeter. Each point will become as 1.1 centimeter or 11 mm. 1.1 centimeter equal to 11 mm. Okay. So I'm explaining one second. So this is your plane scale. On the plane scale, this is my 10 centimeter line. And this 10 centimeter line are divided into 10 equal parts. What are the one part? I will add one more part here. From this one, I'll add one more part. I'll measure this distance. I'll transfer the same distance. So this distance is 10 centimeter. This distance is 10 centimeter. And this distance is 11 centimeter. And now I'm dividing the 11 centimeter into 10 equal parts. So each part will become as 1.1 centimeter. 1.1 centimeter or 11 centimeter. It will become as 11 mm. 1.1 centimeter or 11 mm it will become. Okay. So each part will become 11 mm such as 0, 11, 22, 33, 44, 55, 66, 77, 88, 99, 0. It will become like this. Okay. So each will become, if I want to subtract this and this is my 10 mm. 10 mm. 10 mm by this one, if I make, it will become 11 minus 10, it will become as 1 mm. If I want to measure, this is my 7th point. So 70. 77 by 70, it will become as 7. Okay. So similarly, if you are dividing 22 minus 2, it will become as 0.2 centimeter. Okay. So this is the principle we use in the Vernier scale. Okay. So I will start the construction of Vernier. So example, what the Paul Vernier has done is he has created this one. Suppose if I want to measure 4.56, example, if I want to measure 4.56 meters by using the backward or by using 11th table, how I can divide? Can one tell me? Generally, in the plane scale or in diagonal scale, what we do is we measure this as 4 meters plus 5 decimeters plus 6 meters. 6 centimeters we measure generally. But if I want to measure in terms of backward, in terms of Vernier, what I have to do is I have to take the 6. I have to take this 6. This 6, where it will come in the 11th table. In the 11th table, where it will come, this one, Can anyone tell me? This 6, see only the last digit. Last digit. Tell me where the letter number 6 comes in the 11th table as a 1th digit. Yeah, you have to respond. Where this number 6 digit 6 comes in the 11th table as a single digit. Okay, so it will come at the 66. In the 66, this 1th digit is 6. So what this Paul Vernier has done is he has performed, this is 4.56 and this is 0.066. So what he has done is minus 0.66. This is 0.66 meters. It is 66 centimeters. 66 centimeters equals 0.66 meters. So what he has done is 6 minus 6, it is 0. Then 4.5, 15 minus 6. 15 minus 6, 9 and 3. So from the main scale, you have to take 3.9 meters, and from the Vernier scale, you have to take 66 times. Okay, so what he has done is, so if you see 4.56, if you see 4.56 meters, how it is divided is 3.9 meters, 3.9 meters plus 0.66 meters. Then you can generate the divisions in the Vernier scale. That is what Paul Vernier has done. Okay, I'll give you one more number. How is 123? 1.23 meters. How you will divide 1.23 meters in the Vernier scale? Can anyone tell me? Yeah, can anyone tell me how to divide 1.23 meters divisions in the Vernier scale? Okay, so this digit 3 comes in the 33. So when you are solving the Vernier scale, what you have to do is you have to minus 0.33. You have to perform minus 0.33. Will become as 3 minus 3 0.
0.9.
Yeah, so 0.9. So how you have to make a division is 0.9 meters, 0.9 meters plus 0.33 meters. If you add these both the things, then you'll get the Vernier scale. On the Vernier scale, you have to measure 0.33 meters. On the main scale division, you have to measure 0.9 meters. So similarly, one more problem, 1.43 meters. Can you tell me what is how to measure 1.43 meters in the Vernier scale?
1.1 plus 0.33.
1.1 meter plus 0.33 meters. So this is the 11th table, which is nothing but the backward Vernier. Similarly, if I want to perform the same problem in the forward Vernier, suppose there is a problem called 4.58 meters, and I have to measure this 4.58 meters into forward Vernier, 9th table. What is the value? How I can divide? 4.58, I have to use the 9th table and I have to solve the problem, which is called as the forward Vernier. So on the 9th table, where you get the digit 8 in the 1st place?
2 are 18.
Repeat once again.
9 2s are
9 2s are 18. So I have to separate how much value I have to subtract? It is 0.18. 0.18 I have to separate. So the value comes as 4.4. So by Vernier scale, if I'm solving by the forward Vernier scale, I have to make it as 4.4 meters plus 0.18 meters from the Vernier scale. Then I can get in the forward Vernier. Okay. So I'll give one more time, one more problem. Suppose I'm solving 1.67 meters. I need to have in the backward Vernier and forward Vernier. What will be the value? How to divide? This is my backward Vernier, this is my forward Vernier. How to divide 1.67 meters? Then everyone raise their hands. I'll be taking the attendance. Tell me the solution also. How to divide? What is the final value by using backward Vernier and forward Vernier? How to make the division? How to measure the distance to be measured? So coming to the backward Vernier,
1.4 plus 0.27.
1.4 plus 0. For the forward we use 9th table. Forward we use 9th table. Backward we use 11th table. Okay. So here it comes as 1.4 plus 2.7 meters. What about forward backward?
0.9 plus 0.77.
0.9.
Time is completed, sir.
0.9 plus
0.77.
0.77. Okay. So how we do is here we will be making minus 0.77. We have to subtract here, and we have to subtract 0.27. We have to subtract, and whatever the value we get, we have to add these two things. We will be getting. Okay. Yeah. Still few roll numbers.